13 and 14 ask us only for horizontal asymptotes. Now we did a couple of these in class and from the homework sheet. We know that we're again interested because it's a horizontal asymptote and the limit as x approaches infinity of h of x, and also the limit as x approaches negative infinity of h of x. When x approaches infinity, we have e to a really large number, which is an enormous number. So the minus 5 doesn't matter at all, nor does the plus 3 down here. All that we're really focusing on is right there. So both the numerator and denominator have a growth rate of that e to the x. So in essence, they cancel each other out, and we're left with the coefficients, 2 over 1. So our limit is 2. So y equals 2 is one of our answers. But it's not the only answer. Now we have to take the limit as x approaches negative infinity. Well, from the problem, if we flip back over, I think it was problem number, let's just do that right here. Problem number 9. There we go, right there. Problem number 9, e to the negative infinity, for plugging negative infinity in right here and here, that's 0. So what we end up having is 0 minus 5 and 0 plus 3. So our second horizontal asymptote is negative 5/3. Whether the base is e or 6 or any other positive value greater than 1, it doesn't matter. The process is still the same. When we take a look at the limit as x approaches infinity of f of x, all right, the 6 to the x's rather, are the dominant terms. So this 4 doesn't matter. Nor does that minus 1. My fingers are too fat for this. But we can see here that we have a 6 to the x and a 6 to the x. So in essence, they wipe each other out. We get 1. When we see the limit as x approaches negative infinity of f of x, now these two 6 to the x's both go to 0. So this is behaving like 0 minus 1 over 4 plus 0. So my two horizontal asymptotes are y equals 1 and y equals negative 1/4. 15, we got to fill in some blanks here. All right. G has a horizontal asymptote at y equals 3. Well, by definition, that means the limit as x approaches infinity of a plus bx over x minus c must be equal to 3. Well, this tells us something about b, because we have a limit as x approaches infinity. So therefore, we're going to look for the highest exponent. Boom. Top and bottom. When the highest exponent is in the numerator and the denominator, we focus on the leading coefficients, b and 1. b over 1 must be 3. So obviously b is equal to 3. Regarding the vertical asymptote, that's going to occur when the denominator is equal to 0. We're told it happens when x is negative 2. So negative 2 minus c is equal to 0. If we add c to both sides, we have c equals negative 2. We're interested in b plus c, so that's 3 plus negative 2. So our final answer is 1. And then finally for this assignment number 16, which if any of the following functions have the line y equals 4 as a horizontal asymptote to the graph? So in other words, if we were to take the limit as x approaches infinity of all these f of x's or y's, whatever they happen to be, we want the answer to be 4. Okay, well let's go through them. A, if we take the limit as x approaches infinity of this, we're not going to get 4, we're going to get negative 4. We want 4, so this is a no. However, right here, highest exponents, right? See, notice here is 4x and x. Here is 4x and the opposite of x. So while this leads us to negative 4, this one is leading us to 4. That's a yes. Part C, this is 4x over 1. The highest exponent is in the numerator only, so that limit would not exist. It's a no. Part D, the highest exponent is located in the denominator only, so that's leading us towards 0. It's another no. Part E, cosine of 4x. Well, we know what our graph of cosine looks like. It's our wave function. So it's always between 1 and negative 1. We have 1 divided by infinity. 1 divided by a huge number. So that limit is heading towards 0. Another no. But last but not least, we have f. The highest exponent is located both the numerator and the denominator. So we are going to take our leading coefficients. That's leading us towards 4. So just like b, f is a yes.